Let's explore the differences between a basic model training and an advanced model training. For this example, we will create two models for detecting certain types of screws and see which one is more robust. To start our basic model training, we will create a new project called Screws V1. Then, on the Add Images page, we will select our camera and new project and make sure our screws are in focus. After adding a handful of self-tapping screws to the scene, we will take a snapshot of them. Then, we will rearrange them and take several more to ensure we have a variety of positions, angles, and lighting. Next, we repeat the process with a handful of self-drilling screws. Once we are done taking snapshots, we can move to the Annotate page and generate two new tag types. One tag for the self-drilling screws, and one tag for the self-tapping screws. Next, we carefully go through our photos and tag all the screws by drawing boxes around them. To speed things up, we can use the Ctrl-D shortcut to duplicate a highlighted tag box instead of drawing a new one for each screw. You can change a tag after creating it by selecting it and using the numbers on your keyboard, which correlate to a tag number. Images can also be renamed to help keep the project organized. Now we have 34 tags for self-drilling and 37 tags for self-tapping screws. It's time to save the project and start our training. Under the Create Model settings, we enable Randomly Change Contrast to help with detection under various lighting conditions. We won't randomly scale the samples since the size of the screw is important for identifying its type. While that training is processing in the cloud, we will modify our project by adding more images. To build a more robust model, we need to provide the training with more images and variations. This time we will not isolate the screw types, instead we will photograph them together. We will also throw in some additional screws that may be present in our production but aren't the types of screws we are looking for. By providing the system with additional screw types, we are helping prevent false positives later during identification. If one of the new screw types gets mixed in with our desired screws, the training has already learned that it should avoid it. Once finished capturing our new snapshots, we can go back to the Annotate page and tag our self-drilling and self-tapping screws again. To save time, we can copy and paste our tags from one photo to another. We must be careful not to tag any of the new screw types. This is how we teach the system which types of screws we want to ignore. After finalizing our tagging, we could once again send this project to be trained in the cloud. Around 45 minutes later, our two trainings have completed. To enable the training, we open our prediction settings, enable prediction, and select our first training model. Then, in Capture and Process, we can pull up our camera and load our Screws V1 project. We will be testing our two models using the cloud processing. Let's see if we can trick it by adding some screw types that this trained model hasn't seen before. The system is confused because it hasn't seen these new screw types before, so it tried its best to put them into the self-drilling or self-tapping category. This resulted in a lot of false positives. Let's go back and change the prediction settings to use the more robust training model that we created, where we purposely used images of other screw types. This time we can see that the training was able to correctly identify the two screw varieties while ignoring the unknown ones. By including all variety of screws in our training snapshots, the system was able to ignore them instead of getting confused. This concludes the robust training model demonstration using flexible vision.